So in the diagram, AB is the diameter. Centers O. AB is diameter, center O, and radius 2 centimeters. The point C is on the circumference such that angle COB is equal to 2 over 3 pi radians. State the value in radians of angle COA. 1 mark. And then the shaded region enclosed by the chord AC, the arc CB, and AB is the template of a broach. Find the exact value of the perimeter of the broach. So what we want to do is, I'll put it as a straight line. If you look at this blue straight line I put there, hope you can see clearly. The blue line, which is a diameter, that angle on a straight line is 180 degrees. If we know that 2 over 3 pi is this blue one, to find the pink one, because the whole thing would be pi, so that means to find the pink one, the pink angle, which is angle COA, they use that symbol, angle COA. The symbol for is like the symbol for an angle, or you can just write COA. Angle COA. So O is the middle one, and that angle is there. So it'll be pi 180 degrees, which is pi minus 2 over 3 pi.
Yeah.
And that gives you pi over 3. Think of it as, you can factorize, you can put it in the calculator as it is, pi minus 2 over 3 pi will give you pi over 3. Or you can factorize pi bracket 1 minus 2 over 3. And then that gives you pi over 3. So now got that part 1 done. The shaded region enclosed by the chord AC. Now, the chord is a straight line joining one part of a circle to another without passing through the center. So this chord is in red. You see the line I put in red there? That's the chord. The chord is in red. The arc CB. The arc CB, let's find a color for that. I'll put this bright green. The arc CB is this green color there. That's the arc CB. And AB, which is the blue one, is the template for a broach. So just find the exact value of the perimeter. What does perimeter mean?
The distance, the total distance around.
Yes, we want to find the total distance around that broach. So sometimes I just write the word P for perimeter. So the perimeter, we want to add the red. I'll just use the color. We want to add the red plus the red, which is the chord AC, plus the green, which is the arc BC, plus the blue. Now in your exams, you wouldn't have all these colors to write. So instead of calling the red, you will say the chord AC, plus the green one is the arc BC, plus the blue one is AB, which is the diameter. With all these long questions in A-level exams, it's always good to write down what you're going to do.
Yeah.
So whenever you make a mistake, they call it one error mistake, follow through mistake, and then they only take 1 mark. So they know at least you have a plan. Now we start working out Do we know the diameter? Yes, we know the blue one. We want to find the chord. We know that angle is pi over 3.
We can use the cosine rule. Yeah, the cosine rule, because the two lengths are 2 centimeters.
Was it? Yes, this radius is 2 centimeters, correct? And this one is 2 centimeters. So think about this triangle again. OAC is a triangle, right? You can use the cosine rule. That's the thing with A-level maths. You can use different ways to do it. Is there any other way to do it? You say you can use cosine rule. Can you
Yeah.
see any other way? Okay, let's take that triangle and draw it out on its own. If I draw that triangle here like that, if we isolate the triangle and draw it on its own, and then we want to check certain things in the triangle. We know one side is 2. The other side is 2 centimeters. Which kind of triangle has the same side 2? The same side, the same.
Yeah.
Isosceles triangle, right? If this angle is pi over 3, think of pi over 3. Pi over 3, if you change that to radian, what angle is that?
Um,
60 degrees. So to change pi over 3 to degree, pi over 3 radians to degrees, you multiply pi over 3 times 180 over pi. So to change from radians to degrees, you multiply by 180 over pi. The pi will cancel, and there will be 180 divided by 3. That will be 60 degrees. So looking at this triangle, if one side is 60 degrees, one angle is 60 degrees, the two sides are the same. This is a triangle called equilateral triangle from this information. So if we think isosceles triangle, two sides are the same. So this angle at the bottom, it will be 180 minus 60. 180 minus 60, which will be 120. And then 120 divided by 2, which will be 60. So that means each of this angle is 60. So now that each of the angle is the same, what happens to the sides? They should all be the same, right? Because it's equilateral triangle now. So that side that we're looking for is 2 centimeters. But if you don't, so we can use cosine rule, or you can use that way I've deduced it to get 2 centimeters. You happy with that?
yeah.
You can use cosine rule. Let's write the cosine rule down. Let's see. So that means AC squared, if we were to use cosine rule, AC squared is equals to 2 squared plus 2 squared minus 2 times 2 times 2 times cos pi over 3. Cos pi over 3 is a half. So that means AC squared is 2 squared is 4 plus 2 squared is 4. That gives you 8 minus 2 times 2, 4, 4 times 2, 8 times a half. Cos of pi over 3 is a half. So 8 minus 8 times a half, which is 4. And AC is square root of 4. That gives you 2. So if you use cosine rule, which you said correct, you get 2. If you deduce it that way, that is an equilateral triangle, you get 2. So AC is 2. So now we know the diameter would be the long blue line. We know AC. We need to find the green one, the green curve. How do you find the length of that arc?
L equals RO.
R times theta.
Yeah. Oh, yeah, R theta, sorry.
R theta is that angle there. So we want to find the length of arc. We use the formula right in pink here. L is equal to R times theta in radians. And what is the angle in radians? 2/3 pi. So this is called the arc BC. I should have matched it with the color. Arc BC, its radius is 2 times the angle is 2/3 pi. Multiply those together, it gives you 4/3 pi. So now we know all the 3 things. So the perimeter P, add them all. The perimeter is the chord, which we found out to be 2. I'll put in red. Our chord was 2 centimeters plus the green one is the arc, which is 4/3 pi. Four over 3 pi plus the blue one, which is the perimeter, is 4 cent. The blue one is 4 centimeters plus 4. So 4 plus 2 is 6. So adding these two together, that gives us 6 plus. So the perimeter of the brooch is 6 plus 4/3 pi centimeters. Sometimes we put them in brackets to make it look tidy. So that is how. This is a 6-mark question. Involves cosine rule, if you use it, or length of arc, and some algebra as well. So these are 2 examples of. This is an example of a brooch there. One is red and it's semicircle, another one different color. So they put them on clothes, on hats, and people just wear them and they're made from very expensive materials.